We have discussed what is differentiation, and today we will discuss the motion in one dimension, that is the motion in straight line. We'll discuss integration in further classes. So today's topic is motion in straight line, or you can call it motion in one dimension. So we have discussed what is motion and rest. So if a body an object changing its position with respect to a reference point or frame of reference over a time period, then that object or body is said to be in motion. If a body, an object, does not change its position with respect to a reference point, a frame of reference over a time period, it is said to be that object in a state of rest. So the question arises, what is frame of reference? So the frame of reference describe the nature of the state of any object. Means it describe the quantitative property of the state of any object, whether it is moving or not. It gives the quantitative description. So basically frame of reference is the reference something or reference point. So basically it is a system to which a set of coordinates are attached. So it is the system to which a set of coordinates are attached and with reference to which observer described any event. For an example, let's say a boy is standing at any platform. Here is our platform, and let's say there is a tree near the platform. Now he saw the tree, and with his observation the tree is not changing any position. The tree is not changing its position, so that's why he observed that the tree is in the state of rest. Okay, now let's say here is the boy A, and let's say someone moving in the platform with his bike, any motorcycle, like that, and moving in this direction. Then what he find, that tree is moving in this direction in his in his observation. So this observer A finds that this tree is in the state of rest, and this observer B found that this tree is in the state of motion. So in physics the both condition, okay, in the physics the both condition observer is right, A is right, B is right, okay, but observation are different because in first situation, according to A, he stand on the platform which is reference frame at rest. His frame of reference is rest, okay, and in second situation, according to B, observer moving in motorcycle. So which is reference frame is motion. So the rest and the motion are relative term. It depends upon the frame of reference or observer. Basically the observer, the details of the observer, the quantitative description of the observer can be found if we assume a frame of reference. Okay, so basically frame of reference is a system. Okay, and it gives the quantitative description of any event. So the motion and the rest are relative term. Relative terms. Relative, that is not absolute, it is relative term. If something is moving, that does not mean that according to everyone it is moving. It is a state in motion. Okay, it is relative. It's depend upon the observer, means it's depend upon the frame of reference. Okay, for perspective of A, this tree is in rest, but in the perspective observation of B, we observe that this tree is in the state of motion, and in physics both are right. Both observation are valid. So motion and rest are relative term. It's depend upon the frame of reference. Frame of reference means reference point or surrounding. Surrounding is a basic term, and reference point is also a basic term, and the frame of reference is a broad term because it gives you a quantitative description of any event. Now let's say you are sitting on a terrace. Your friend comes and see that you are in the state of rest, and suppose that any observer at moon or any at any point of space, what will he see? If he sees you, what will be the observation? So he he'll find that you are in the state of motion. Why? Because earth is moving. That's why you are also moving. So the motion and rest are relative term. Something is moving according to you, and that thing is in rest according to someone else. It can be rest. Depend upon the frame of reference, means depend upon the reference point. Next, we have discussed that what is physical quantities. Physical quantities are the properties of any physical event. Okay, and there are two types of physical quantity. First one is scalar quantity and second one is a vector quantity. A scalar quantity are those quantity which have magnitude, only magnitude, which has only magnitude, like meter, sorry, like a length, like a distance, like time. All this quantity has only magnitude. So if you have to describe a physical quantity, sorry, if you have to describe a scalar quantity, then you just need numbers. Okay, but some physical quantities need magnitude as well as direction to describe it. For example, displacement, force, weight, these are the quantity which need a magnitude, that is the number, and a direction. All physical quantities need a magnitude. All physical quantities has magnitude because physical quantity is a measurable quantity. So if you can measure something, that's mean you can give a quantitative description, means you can describe physical quantity in terms of numbers with a unit. Okay, but some physical quantities need numbers as well as direction. So this number is magnitude along with the unit, whatever unit is, and some quantity needs numbers with a unit along with a direction. So we have discussed that. That is the quick recap of that physical quantities. Now the topic is distance and displacement. So we know that a distance is the actual length of a path covered by a moving object in any time period. For example, let's say here is a 3 point A, B and C. And this one is C. Let's say a boy, a person, or any particle goes A to B, B to C. The length of the path of AB, let's say 3 meter, and the length of the path of BC, let's say it's 4 meter. So here the distance traveled by any object, any person from A to B to C is the total length or total length of the path. So here A plus B, AB plus BC, that is 3 meter plus 3 meter plus 4 meter, that is 7 meter. So we can say that the distance covered by any object, any particle, any person from A to C is 7 meter. Now distance is a scalar quantity. We have discussed that distance is a scalar quantity, means you need only numbers, only magnitude to describe distance. It does not depend upon direction. And the dimension of a distance, basically distance is what? Distance is length, and we have discussed that what is dimension in chapter number 2. So here we write a description dimension formula like ML T. M for mass, L for length, T for time. So here distance is a length, that's why the power of the length will be 1. And the power of mass, there is no mass in distance, so 0, and there is no time in a distance, so 0. So that is M0, L1, T0 is the dimension of the distance. And what is the unit? So the unit of distance is meter and denoted as small letter m. That is the SI unit of distance. And the CGS units will be centimeter. We have discussed that. Centimeter. Now, next term is displacement. Displacement is a distance along with a direction. So basically it is length with a direction. So that's why it is a vector quantity. So it is a length, so dimension will be same as distance, so it will be m0 l1 t0, and the SI unit will be same because this unit only describe the magnitude numbers, so meters, and denoted as small letter m. Now for this case, suppose for this case A to B, there is a movement of any particle or person. Let's say he moves from A to B, B to C. Now we have discussed that what is the distance. So the distance covered by this person or this object is 3 plus 4, 7 centimeter. But what will be the displacement covered by that person or object for this path? So basically displacement is just change in position. It is a vector quantity. So displacement is the straight line between initial position and final position. It is the straight line because the straight line has a direction. So the straight line between A and C here. So the length of the straight line between, or length of a straight line draw between initial point, that is the A, and the final point is C. That gives you the displacement. So from we know that let's assume it is a base, it is the perpendicular, and it is the hypotenuse. Okay, so we have to calculate the length of this hypotenuse of this right angle triangle. So now we know that from mathematics geometry, the hypotenuse square will be sum of perpendicular square plus base square. Okay, then the hypotenuse will be root under root p square plus b square. So here p square, that is AB, is 3 square plus sorry, the p square is not 3, the perpendicular square is 4 square, and the base is AB, here is 3 square. So this will be 16 plus 9, 25, that is 5 meters. Okay, so you can see that the distance and displacement is not same for this path. The distance only depend upon the length of path, actual length of the path, but the displacement only depend upon the length of final position, initial position and final position. So we have to draw a straight line between the final position and initial position, and the length of this straight line gives you the displacement, the value of displacement. Next, there are some property and difference between distance and displacement. For a moving body, distance can never be negative or zero. For a moving body, a object, a person, distance can never be negative or zero, while displacement can be negative or zero for a moving body. Okay, how? Let's say there is a boy at point A, here is a point B. Let's say this boy moves point A to point B, and the length of this path is, let's say, 100 meter. Okay, so he moved from A to B. For this particular case, the distance is 100 meter, and displacement is also 100 meter. Let's say after reaching this point B, he decided to move back its initial point. So again he moves from B to A. Now what will be the distance? So here the distance will be AB plus BA, that is 100 meter plus 100 meter is equal to 200 meters. So this situation, this case, the distance is 200 meter. Now what will be the displacement? So this, for this particular case, displacement is what? Displacement is the length of straight line draw between initial point and the final point. Now let's say the initial point is A and the final position is also A. How? First he moves from A, that is the initial point, reaches B, then back to again A, then final destination is also A. So what is the straight line or line draw between initial point and the final point? In this case the initial point is A and final point is also A. So the length of the length of the straight line draw between A and A is 0. You can't draw a line with a single point because the final position is here and the initial position is also here. So this will be 0 meter. Next, let's say this person moved further in this direction, let's say in this direction, and reaches at point C at 50 meters is the length from A to C. So now what is the distance for this particular case? Again, distance, let's say distance is AB plus BA plus AC. So here is 100 meter plus 100 meter plus 50 meter, that will be 250 meter. What will the displacement? So the initial point is here and the destination is here, means the final point is here. So the length between here is the length between straight line draw between the A and C is 50 meter. So 50 meter, but displacement is a vector quantity, so there is a direction associated with the displacement. So let's say this direction, he moving in this direction, so north, and this direction is west. Let's say north direction, we take north as a positive direction, so the west will be in negative direction. So basically first he moves in this direction, positive 100 meter, then negative 100 meter, total 0. then negative, he moves in negative direction 50 meters, so it will be negative 50 meters. So that's why displacement of a moving object, a body, can be zero and also can be negative, but the distance can never be negative or zero for a moving body. Now, speed and velocity. We have discussed what is speed and velocity. So speed is what? Speed is just a rate of change of distance with respect to time. Basically, the speed gives us the idea of how something is moving, means how fast or slow is something is moving. Okay, so it is a scalar quantity. It is a scalar quantity and it's depend upon the distance. So we can say that speed is a function of distance. What is the dimension? So basically, speed is what? Speed is distance upon time. So here is the length, here is the time. So what will be the dimension? M, L, T. So m, there is no mass in a speed, there, and yes, there is a length in a speed, and the time, there is a time in a speed. So the speed depend upon the time and the length. So that's why the dimension of this speed, dimension of the speed will be m0 l1 t the power minus 1. Okay, and what will be the unit? So the SI unit for length is meter and time for second. So meter per second for SI unit, and for CGS unit length, the CGS unit of the length is centimeter, and second for time. So this will be centimeter per second for CGS unit. Now next one, velocity. Velocity is just a speed with a direction, means it is a vector quantity, and the velocity is just a rate of change of position. Basically it is rate of change of displacement with respect to time. So the velocity will be displacement upon time. And what will be the dimension? So basically the velocity is just a speed with a direction. So the magnitude will be same as a speed, so the dimension of velocity will be same as a speed, so it will be same l0 l sorry m0 l1 t minus 1, and also the unit will be same, meter per second for SI unit, centimeter per second for CGS unit. Okay, next we will discuss the types of speed, like uniform speed and non-uniform speed, and also we will discuss the type of velocity, that is uniform velocity and non-uniform velocity, and instantaneous speed and instantaneous velocity. We have discussed the calculus, Basically, we have discussed that differentiation. So it will help us to understanding the um, instantaneous velocity. Okay. So in next class we will discuss that terms.